So, how AstraZeneca made a dosage mistake on their COVID vaccine, aka why learning chemistry math matters. I am Blake Harwell, and today I am teaching my advanced topics in chemistry class, and we are going to listen to a short article about a mistake that AstraZeneca made when they were diluting uh, their coronavirus vaccine. So pay attention for the mistake they made in the video, meaning the audio.
COVID-19 vaccine was 70% effective in preventing the disease. But as the week wore on, questions began to surface about how reliable that result was. Joining us now to discuss some of the issues that have come up is NPR science correspondent Joe Palca. Hi, Joe.
Hi, Ari.
So what's the problem? Explain why that 70% figure might not be reliable.
Well, it's probably accurate in terms of a number, but part of the reason, at least for now, is the company hasn't said a lot about how they arrived at that number. But one thing does seem to be clear, that instead of doing a simple study involving two groups, where one group got 2 injections of a vaccine and the other group got 2 injections of a placebo, and then you compare the groups, they had a lot of different groups with different doses carried out in parts of different studies, and that makes it really hard to interpret the results.
Before we dig deeper into that, Pfizer and Moderna also reported good results for their COVID vaccines. Are these likely to also come under scrutiny?
Well, they're certainly going to be scrutinized very carefully, I should say, but they did do things in a more straightforward way. There were 2 groups. One got the vaccine, one got the placebo, and in both cases they showed more than 90, almost 95% efficacy. Although, again, I have to say that almost all of what we know about the Pfizer-Moderna results and also the AstraZeneca-Oxford results comes from press releases. So scientists have a lot of questions that they don't have answers to, like who benefited the most from the vaccine, what age groups, what genders, what kinds of underlying conditions made a difference. So a lot of questions still.
All right, so to go back to the AstraZeneca-Oxford vaccine with this complicated design of the test, the results showed 70% efficacy, as we said. But I remember in your first report on the subject, you said for some groups it was 90% effective if they got half a dose. Is that right?
Yeah,
How did that work?
Yeah, well, that's one of the really strange things, and it's one of the things that's raising scientific eyebrows. The vaccine is given in 2 injections, and a subset of patients wound up getting a half dose in the first injection and a full dose in the second injection, and that group actually did better, around 90% protection. So Mene Pangalos, who is the executive vice president for biopharmaceuticals and R&D at AstraZeneca, said at a news conference that the company said, we're going to use that to suggest making changes to a large study that's underway in this country and include a group that gets the half-dose, full-dose regimen.
We will try and do that as quickly as possible. We need to have, obviously, a change in the protocol. We need to have a conversation with the FDA, but I would put that in a matter of weeks.
Okay, let's go ahead and look at the Blackboard configuration. We're still in Unit 3. We're still looking at intermolecular forces, mixtures, whatnot. Our objective today is that a solution composition can be expressed in a variety of ways. The main way we're going to express is molarity, and that you're going to be able to use particle models to draw concentrated and dilute solutions. Could I have a student read the student-friendly objective?
I can use the dilution equation to calculate molarity of a diluted solution. I can draw particle diagrams that represent dilute and concentrated solutions.
Awesome. Thank you very much, Shailene. Okay, so what are we going to learn? Well, we're going to learn how to dilute a solution and how to draw these particle diagrams. Why are we learning this? I think it's probably pretty clear. We're learning this because AstraZeneca made a mistake doing this. And wouldn't it be cool to learn how not to make that mistake again? How do we know we're going to learn? I'm going to observe you in your groups. You're going to have an exit ticket. And there's the agenda for the day. Okay, so this is, you need to be jotting this down in your notebook. This is the dilution equation. M1V1 equals M2V2. With M1 being the first molarity, V1 being the first volume, M2 being the second molarity, and V2 being the second volume. What are the units for molarity? Anyone?
It should be moles over liter.
Yeah, moles over liters. Awesome. And the units for volume are just liters. Okay, so if you haven't written this down yet, screen capture because I'm about to move on. Bam. Okay, so you're going to need to pin my camera so that you can see this problem. Pin my camera to your screen. Whatever. So we've got the molarity. We've got the equation already written. If I had 340 milliliters of a 0.5 molar sodium bromide solution, what will the concentration be if I add another 560 milliliters of water? Well, let's start out like we start any problem by writing down what we're given and what we're looking for. So my initial molarity is 0.5 molar. My initial volume is 340 milliliters. But on the last slide, we learned that volume has to be represented in liters. So I'm going to convert that to liters. My second molarity, they don't give it. That's what we're looking for. And the second volume, it's going to be 560 plus 340. All right, so let's plug that into our calculators. And that's going to make 0.9 liters. From here out, it's just a matter of plug and chug. So take about 30 seconds, plug and chug your answer, and type them in the chat box. Okay, I think you probably had time. Does anyone have the answer?
Would it be 0.189?
That's exactly right. 0.189 molar. And let's look at these two molarities. Initially, it was 0.5. Now it's much, much smaller. What have we done? We've done a dilution. We've added water, and it's decreased the molarity. Okay, so let's go ahead and get into our breakout rooms. It shouldn't take more than about 4 or 5 minutes, and then we'll come back together. I'm going to pop in and visit. If you have any questions, type them into the chat box. Awesome. Group 4 is working well. Very good. Group 3. Oh, I'm seeing some math happening already. Very good, guys. So on the Google Slides right now, students are all able to simultaneously work on the same set of slides. The volume is turned off because we found that if your sound is turned on, it causes a lot of feedback. So the students primarily communicate via the chat box. Very good, very good. Awesome. Slide 3.
I'm gonna do slide 4.
Awesome, awesome.
So, like, when you say you carve, you mean like dots, right?
Well, so I already, are you on slide 4?
Yeah.
So like I put them right over here.
Oh, okay, okay.
So it's like you drag them, just click on one of those and drag it. There you go.
Oh, okay.
No, keep them small though. Oh. They're all the same size. Freddie, I really like the way you are showing your work, even on the Google Slides. That's really nice. or whoever is person 2. Lillian, make sure that your group uses units, and especially in your answers, okay? That's looking good. Very good, guys. Very good. And it looks like most of us are finishing up the 2 math problems. Let's look at the particle diagram. Oh, very good. So we've got the RNA. Avery, you want to come explain this particle diagram to me?
Well, logically, I counted all of them up, and I'm going with like a logical approach that when it says half dose,
Mm-hmm.
that it gets,
Yeah, no, you're exactly right. So you have like 12 here
yeah.
and 6 there. That's perfect. Very good.
What, you said add more?
No, I said that's perfect.
Oh.
Very good. On problem number 1 in group 2, the total volume, if the initial volume is 0.75 and we double the volume, what will we need to do? We'll say, what times 0.75? Yeah, that's exactly right, Jaylene. Very good. Okay, so anytime we're stuck, we want to start off by writing down what we're given. So go ahead and write M1, V1, M2, V2, and then let's try to start labeling what they gave us and what we're looking for. That's right. Good, good. Exactly. Okay, so now that you've done this, do you know how to go from here? Awesome. Let's watch this. Very good. Okay, guys. It looks like most groups are sort of wrapping up. And it looks like all of us are doing really well. Take about 1 more minute to wrap up, and then we'll come back together. To the main room. You can leave your breakout rooms open, but come back to the main room. I have 1 or 2 people tell me, what did you learn today? Just unmute yourself and let me know.
I learned a new equation.
Yeah, you learned a new equation. And would you make the same mistake that the AstraZeneca scientists made?
Probably not.
Probably not, because you know the equation, you know how to do it. Very good, very good. Go ahead and answer the exit ticket. And then we will move from there.